Last week we learned about the history of our atmosphere, the ancient history of it, in fact, 4.4 billion years ago and everything in between. And we learned how modern scientists were able to use fossil records of early single cellular life forms and even ancient crystals to determine, using modern techniques, what was there long before we were. But for this video, we're going to delve into what older scientists did with newer stuff. See, before we had the Jack Hill's zircon, we had a man named Evangelista Torricelli, and he had a tube full of mercury. I'm Sparrow, and I'm a science communicator with a background in behavioral science and pedagogy. And this week's video is also on the atmosphere. In 1643, Evangelista Torricelli invented the barometer, but it didn't look like the one we use today. It literally was a tube of mercury. And the way it worked was that the pressure inside of the tube would react to the pressure on the outside of the tube, causing the mercury to expand and fill the tube, or to compress and become lower. This is really similar to how if you have a water bottle in your car and you're driving up a mountain, for example, to go skiing or snowboarding, the water and air inside will react to the change in air pressure outside, and when you open your bottle at the top of the mountain, it will poof out. Conversely, going down the mountain, it will crunch in. He was able to calculate the measurements needed to delineate levels of pressure based on this. And so in 1648, his barometer was brought up a mountain, which I hope I'm pronouncing correctly, called Puy de Dôme, by Blaise Pascal and Florent Perrier, to measure the differences in pressure at various altitudes on that mountain. They noticed that as they got higher up, the pressure became lower and lower and lower, and they hypothesized that if you got far enough from the center of the Earth, or high enough in the air, you would reach the vacuum of space. This was the first time anyone had thought of space as being empty. And as a fun little aside, using their idea, Torricelli actually created the first earthbound vacuum, which was not a vacuum cleaner. It was actually a true void made in a lab. But that was the inspiration for the vacuum cleaner. And if you're interested in that, you can learn more about it, or who knows, maybe I could do a video on it. Comment below if that's something you would be interested in. In 1709, Bartholomew de Gusmão invented a passarola, which was similar to a paraglider if a paraglider, a kite, and a ship had a baby that would fly in the air but not carry people yet. His idea was to eventually create a sort of airship, and it did lead to the creation of zeppelins and hot air balloons and even the airplanes of today. This was funded by King John V of Portugal. In 1774, Joseph Priestley isolated and discovered oxygen, the element. He was measuring the rate of molecular decay for other materials and discovered it sort of by accident. In 1783, Joseph Michael and Jacques-Étienne Montgolfier embarked on the first manned hot air balloon flight. They were brothers, so same last name. In 1787, Horace Benedict de Saussure, I hope I'm saying that right, hiked up Mont Blanc, and he took various temperature readings at various altitudes. And he learned that it got colder as you got higher up or farther from the Earth. And he hypothesized that at some point it could theoretically get cold enough for all molecular activity to stop, and coined the term absolute zero. Scientists today agree that this is possible and has occurred somewhere in the universe. However, we've never measured it because it would kill us and destroy all of our instruments to try. But we've come close. There is a crater on the moon that never sees light and reaches 410 degrees below Fahrenheit, which is only about 49 degrees above what absolute zero is hypothesized to be. In 1862, the highest altitude hot air balloon manned hot air balloon flight occurred. That was Henry Coxwell and James Glaisher. They were measuring temperature and humidity at various altitudes with the goal of determining ways to predict the weather. And if this sounds familiar to you, you've probably seen a movie called The Aeronauts, which is in part based on their expedition. However, they gender swapped Henry Coxwell's character in order to make it more dramatic and interesting for audiences. In the movie, there is a vital scene, which, I guess, spoiler alert, if you haven't seen the movie, skip forward like 30 seconds. I'll do like this with my hand. In the movie, there's a scene in which they go so high that James Glaisher's character actually loses consciousness and the female character loses sensation in her hands. This actually happened in the real flight. And in the movie, she has to climb up on top of the balloon and use her shoe to wedge open the vent. And in fact, in real life, Henry Coxwell did have to climb up and manually open the vent because it malfunctioned, and he had to do it without feeling in his hands. And just like in the movie, he actually lost consciousness before determining whether or not they were safe. He was able to open it, but before they started losing altitude, he did lose consciousness, and they regained consciousness as they landed safely. Very cool stuff. If you haven't seen the movie, I recommend you see it. And in 1869, the stratosphere was discovered. This was the first time anyone realized that there were different layers to the atmosphere which had different behaviors and compositions, in addition to the variations in temperature, pressure, and humidity that were here in the troposphere. This discovery was actually made by two different men in two different countries within days of each other. Leon Tessier, oh, I'm so terrible with pronouncing these names, and Richard Assmann, which is a lot easier to pronounce but a little bit funnier to say, both independently discovered it and presented it to the scientific and meteorological societies of their respective nations within days of each other, and so both are given equal credit in the discovery. After that point, we started using rockets and robots to study our atmosphere, by which I mean unmanned air balloons and drones and actual space rockets with probes attached. We also used gases isolated in laboratories to study their properties and behaviors and make inferences about the atmosphere, because all of that is a lot safer than going up in hot air balloons and hoping you don't die after you pass out from the altitude. From all of that, we know that our atmosphere has layers. The farthest from the Earth is the exosphere, which is technically considered space, but because there are gases in it, and it is reacting to the Earth's gravity, we still count it. There's the thermosphere, which is named because temperature variances do not occur within it the way all of the other layers do, which is technically magnetic and contains the ionosphere, which is not a layer of atmosphere, it's just another roughly spherical layer, which is comprised of iron and other particles that were spat out at us by the sun and became caught in our magnetic pole, which is different from our gravity. The magnetic pole is created by the spinning of the core, and if you are interested in that, I can do a video on that as well. Please comment below. The mesosphere is what burns off all of the meteors that try to hit our planet, and if you see a shooting star, you're actually seeing a meteor get burned up by the mesosphere. Then there's the stratosphere, which filters ultraviolet radiation and makes it possible for us to not get immediately instant cancered by the sun. And the thing in the stratosphere that does this is our ozone layer. And comment below if you would be interested in an ozone layer video, because there is actually some really cool history there, especially when it comes to conservation and inventions and pollution and crazy science, and a Nobel Prize winner who almost caused the extinction of the human race. And of course, the final layer, the layer that all of us life forms love the best, is the troposphere. That's where all of the air we breathe is at. Now we know, in addition to all of this, the composition of our troposphere. The vast majority of it is nitrogen, about 78%. And nitrogen is really important, not only because bacteria and plants like it, but it's far more important to the rest of us, because nitrogen is what prevents the sun from setting the oxygen we need to breathe on fire. Oxygen is super reactive. It will bond with just about anything, and it will also catch fire very easily. And without nitrogen sort of mixed in with it and acting as a buffer, all of the air we need would just be fire right now. 21% of our atmosphere is oxygen, and oxygen has two main jobs. In the form of O3, or ozone, it filters UV radiation to keep us safe. In the form of O2, it is used by bacteria, plants, and animals, like us, to breathe and process nutrients. The next most common gas in our atmosphere is argon, with 0.9%. Argon is inert, that means it doesn't bond with anything, and its main job, like nitrogen, is preventing our oxygen from catching on fire. It also is weirdly good at filtering out noise and reducing heat transfer. And so argon plays a role both in moderating our climate, but also in preventing us from being exposed to the constant, endless noise of space. Which is a funny thing to think about. You always think of space as being silent because space movies are silent. But of course, space movies are not filmed in space, and no one can really hear what's going on in space because our ears rely on the movement of particles, and there aren't particles in enough profusion in space for us to be able to hear them. However, space is actually incredibly noisy and incredibly hot, to the point that if even like one particle went in our ear to give us that sound, it would be louder than our brains could tolerate, which is a little terrifying to think about. But anyways, if you are interested in space videos, please comment below. The last major player in our atmosphere is, of course, carbon dioxide. And we hear a lot about that on the news. We hear a lot about global warming. And so it's easy to think that carbon dioxide is bad, but that is not the case. Carbon dioxide has a couple of very important jobs. It is breathed by bacteria and plants and also used in processing their nutrients. And it also absorbs and distributes space heat so that we don't get as cold as the moon here. Without carbon dioxide, there would be no life on Earth. That is my high-speed video, and I'm going to not look at it and edit it because I am just completely out of spoons this week. So please like, please subscribe, please, please, please comment, and I will see you all next week.